In Module 7, starting up this week, we are going to start by looking at a function, both equation and graph. This particular story is about a mechanical device that is used to launch a potato vertically in the air. The potato is launched from a platform 20 feet above the ground with an initial velocity of 92 feet per second. The function, this, models the height of the potato over the ground in feet a certain number of seconds after the launch. Here's a graph representing that function. A few things to notice. The 20 is the c from standard form, and that is our y-intercept, and also gives us our initial height. The negative 16, if you remember from the last unit, that is the acceleration of gravity in feet per second squared. And it is negative because anything that goes up has to come back down. And we know negative quadratics create a U shape with a maximum. The 92 is where we would place the velocity with the plane t. So h of t is what this function is called. It's all about height. So if we were talking about like y equals negative 16x squared plus 92x plus 20, this is the same exact function, but instead of calling it y, we're being more specific and we're calling it height over time. So instead of using x, we're using t because we're talking about time. These algebraic things they're not meant to confuse you. It's supposed to be to give you more detail. So number one, what is the height of the potato 1 second after launch? If we look at 1 second after launch, this is the height of the potato. So it looks to be approximately 100 feet. Approximately. 8 seconds after the launch, will the potato still be in the air? Well, not unless somebody relaunches it, right? Because it looks like it's going to hit the ground approximately here. So I just answered question 4. When will the potato hit the ground? Approximately 6 seconds. Will the potato reach 120 feet? Well, let's look at 120 feet and see if the potato ever touches that spot. Turns out it hits right here and right here. So yes, it does, and it happens 2 different times. At approximately 1.5 seconds and approximately 4.5 seconds. Now, something I'd like to talk to you about, the graph is a great way to get some information. It's a great way to understand the model of what's happening. But as far as very specifics, we need to use our equation to get more specific. So when it says, what is the height of the potato 1 second after launch? Our t is 1. And the question is, what is the height? So in algebra, you will see h of t, the function height as time goes on. So the question would be, what is h of 1? What is the height at 1 second? So everywhere in that equation, we would put a 1 where we see the t. And if you type that into your calculator, I'm going to do that with you. So negative 16 times 1 plus 92 plus 20. The height is actually 96 feet. Okay? So after 8 seconds, let's see how close we were. We said that the potato would definitely not be in the air, but let's look at h of 8. So everywhere you see a 16, instead, I'm going to change colors. We're going to put an 8 there. So we have negative 16 times 8 squared plus 92 times 8 plus 20. Ooh, negative 268 is our answer. So is that a valid answer for height of a potato? I would say no. The function continues. Remember, x squared functions have little arrows on the end. Like they're going to go on and on forever. But for our story problem, the only part that makes sense is happening here in quadrant 1, where we have a positive time and a positive height. After this thing hits the ground, it's over for the potato. Just squished. Maybe it's a mashed potato, maybe it's a diced potato, nobody knows. So when the potato hits the ground, if we were dealing with the algebraic side rather than the graph, we would take our equation and we would set it equal to 0, because our question would be, when is the height equal to 0? And we would solve this. We're going to be doing more in this unit to learn to factor this, put it in factored form so we can find the answers. We're going to be learning how to solve these more as we go on, but that's kind of a precursor to what's going to be happening. Those of you that are in class will be doing part 1.2, but those of you that are at home will not. It's pretty much the purpose of part 2 is to create a frame that looks like this, where it's perfect on all sides of the picture. And what the kids at home are going to find out is that you cannot cut this perfectly because we do not have a very easy measurement. So let's just go ahead and go over to 1.3 for those of you at home. Here's a diagram that shows the pictures with the frame that is the same thickness all the way around. The picture is 7 inches by 4 inches. The frame is created from a 10 square inch scrap of material in the form of a rectangle measuring 4 inches by 2.5 inches. So this is like a piece of paper for the kids in class that's 2.5 inches by 4 inches, and they had to cut this into 4 strips and put it as the frame. So that's what's going on here. All right. Write an equation to represent the relationship between the measurements of the picture in the frame and the area of the framed picture. So we're going to have an equation that's got to have 2 things going on, the measurements and the area. Okay, so in order to do this, we need the measurements and the area. So the area of the picture is 7 times 4. The area of the frame is 10 square inches. So our total area is 38. Okay, well, we know all of these little sides are equal. So let's just call that x. We do not know the measure. We just know it is some measurement. So the area of the entire picture with the frame is, we have to figure out a way to describe this width, and we have to figure out a way to describe this length. Well, the width is, this part is 4. I need a brighter color there. This part is 4. So we're going to have 4 plus x plus x. Total width is 4 plus x is plus 2x. The length is a 7 for the picture, but then it's got 7 over here, x over here and x over here. So the total length is 7 plus 2x. When I have my area is length times width. So if I have length times width, we know the total area is 38. So we have created an equation knowing that all the sides frames were x inches long for the total area of this particular picture. What would a solution to the equation mean in this situation? So if I could find a solution to this situation, that would give me the width of the frame. Okay, so what we're going to do is I'm going to use Desmos, and I'm going to put this into the calculator, and we're going to find out when is the y value 38. So let me pull up Desmos. Let me see if I have it opened. Nope. So let's get this opened. Desmos graphing calculator. Here we go. Seven plus 2x. Whoops. 2x and 4 plus 2x. Okay, so this is the graph of the function. So let's find out when is the y value, or the area, equal to 38. Well, there we go, right about there, about 0.42. So what does that mean in the story problem? If we know that this happens when x is equal to 0.42, that is telling us that 0.42 is the width of the frame. Kind of cool. So we're setting up a quadratic function, which if you don't believe me that that's quadratic, what can you do to see it in standard form? You can create your little box and multiply all of it out, and you will see this is 4x squared. There's your quadratic. You will see this is 28, 14x, 8x. So there's your little quadratic equation. Notice that the 28 is the y-intercept. So that is actually the 28 being the y-intercept. What that's really telling me is that right here at the beginning, at 0, it was 28. That is your original area for your framed picture, right? Then you're adding little bits of frame all the way around, and this is what's happening to your area. It's going up and up and up. The question is, when was the frame equal to 38? At 0.4. So I hope this was kind of interesting to you, that we can find out measurements like that using all of this quadratic stuff. I would very highly recommend that you go ahead and read through the summary. It is a great way to make sure you know what's going on. Notice it has some of that function notation stuff going through there. F of 0 means the function at time 0, function at time 2. But please read through that, and then don't forget to go back and do your homework assignment, the problems that have been assigned. Check and see which one.